Hi, I'm Ben. I'm from Melbourne, Australia, and super delighted to be here at the first NG DE-Conf. So thank you so much for having me. Today, my talk is called Performance for the Long Haul. This is knowledge that we've picked up over the last few years of building Calibre and working with hundreds of organizations all over the world and helping them on their performance journeys. So hopefully today I can impart some knowledge from that journey, and it should be fun. So we're going to kick it off. As builders of the web, it's our job to ensure that the sites and apps that we build are performant and accessible for everyone. It's well understood that performance is a defining factor of great products and services, but unfortunately, performance is seen as an additional step rather than being part of the process. An internal study at Google showed that 40% of organizations who did make a big effort in terms of performance, and we're going to fix this, regressed after only 6 months. It's clear that bolting performance on just doesn't work. For performance work to be successful, it must be part of the process from beginning to end, or at least during regular check-ins. So we don't have this situation where we work on the project for the entire lifetime, and then we get to the end and somebody says, hey, why is this so slow? And their voice goes really high. And then everyone scrambles to try and fix it. What works far better is when you make performance part of the process from beginning to end. So in order to understand the types of performance issues that are most impactful on the web, it's useful to understand the biggest performance offenders. So once you've developed a feeling for the types of issues that are out there and how to diagnose them, you'll find performance work to be less of a burden. And I think there's every chance that what I'm about to describe is something that you'll be very familiar with on your own projects. Two of the most prevalent performance issues that we commonly see are JavaScript, the amount of it, and its runtime, and the number and size of requests. And there are plenty of other subtle performance issues, but these two have the most impact overall, and we're going to start by diving into those and explaining them a little bit. So, big issue number one is that JavaScript is executed on a single thread. Without question, JavaScript is the biggest or the largest influencing factor to performance on the web, and it can be categorized into two simple phases. Firstly, we have pause and compile, which is immediately what happens after a script has been downloaded to your device. And then secondly, we have the runtime of that JavaScript. We're gonna step through those. Due to the CPU and memory limitations of mobile devices, they're the most susceptible to being negatively influenced by JavaScript. Take note that these issues do apply to desktops in every single way, it's just that they're more obvious on phones. So here we're comparing an LG Nexus 5X, which is 149 euros, and it has a benchmark score that you can see is about a quarter of an iPhone X, which is some 7 or 8 times more expensive. When your browser has finished downloading JavaScript, it's then uncompressed, turned into an AST, then compiled to bytecode, and executed on your device. By the way, I stole this from Adi Osmani's fantastic JavaScript 2018 article. Didn't draw it myself, but still, it's fantastic. So the more script that you add, the longer this process takes. Parse and compile can be difficult to understand at first, and here's why. We've been taught to look at the over-the-wire compressed size of a script, and we use that as a rating of how big a script's impact will be. Looking at bonappetit.com, we can see that there's 2.36 megabytes of JavaScript over the wire. The problem being is that when we uncompress that script, it blows out to 11.5 megs. And that's what the device has to deal with. So suddenly, instead of having this 2.3, which seems maybe kind of modest, but actually sounds like a bit, it balloons out to 11.5 megs. On a low-end device, this can really mean some bad things. The size of scripts directly impacts how long parse and compile takes, and it's the thing that causes devices to stop just rendering, or for scroll to be not smooth, or that situation where you're scrolling and then the browser freezes and then it scrolls to the bottom of the page and then you've tapped on an ad and then you're not looking at the thing you wanted to look at in the first place. So it's really important to look at the uncompressed size of scripts because they have, the compressed size has little to do with parse and compile. Oftentimes, a script, rule of thumb, can be 3 to 5 times larger than its compressed counterpart. Parse and compile can be visualized by opening Chrome's DevTools, clicking on the performance panel, and then using the reload and start tracing button, or the start tracing and reload button. And so in this demonstration here, what I've done is I've gone and done that, and we can see this huge timeline across the browser. So what we're looking for on this timeline here is this evaluate script item. We can pull the panel up, and we can see how long that process takes. For bonus points, we can also use Chrome's DevTools to then go and throttle the network, like a device would be maybe throttled when it was out in the field. And also slowing down the CPU helps to, it actually will delay every single function in its duration, as well as the parse and compile. And so that's a really good way that you can get an insight without having a device on hand to see that process. So scripts that can be parsed and compiled in 40 milliseconds on a desktop may take up to 350 milliseconds on a slower mobile. So I can't stress the importance enough of actually going and doing this on a proper device. And we're going to cover how we can go through that process a little later on. JavaScript runtime is literally the time that functions take to run on that same main thread. You can visualize it in the same way by creating a performance trace in Chrome or your favorite browser of choice and looking for tasks. As a rule of thumb, we want to keep our functions fast. We want to keep those functions to less than 100 milliseconds in every case on every single device. So that means that function that was maybe 50 milliseconds on a desktop, we've already definitely blown past that on a phone. Jacob Nielsen, who's a usability expert, wrote in 1993 that 100 milliseconds is the time that a delay becomes noticeable to a user. So if they've clicked on a button and they're waiting for a panel to slide out or for some interaction to occur, after 100 milliseconds, people are going to notice it. So if you have a function that's maybe iterating over a large DOM or doing animation in JavaScript, that's where you're likely to see delays, and that's where your users are likely to become frustrated. For particularly complex scenarios, it can be useful to separate areas of your scripts or your app into using web workers or service workers. And the reason for that is that they run on their own thread. And so user interactions will be less impacted. If you wanted to quickly assess where your JavaScript is at, and I guess without having to open a panel in your browser, and you wanted to somehow monitor these processes, we can look at 3 particular metrics, and we're gonna talk about those in a little bit more depth today. Firstly, the total uncompressed size of a script, time to interactive, and total blocking time. Has everyone heard of time to interactive? Yeah? OK, cool. So what is time to interactive? When we're looking at when a user navigates, we're looking for, we have different paint events that describe a user's journey. So one of the common metrics that we talk about is first contentful paint. First contentful paint is literally the time when content is first visible on the screen, aka text. So if you're using a web font, you may be delaying your first contentful paint until that web font has been downloaded and then displayed. The way that time to interactive is calculated, though, is we look for the first contentful paint, we analyze the main thread, and we're looking for tasks or JavaScript functions. Specifically, we're looking for tasks that run in less than 50 milliseconds. So if you imagine this timeline going across the screen, firstly, we look for the FCP event, and then after the FCP event, we're looking for a period where there's no network activity, so nothing is being loaded, and there are no long tasks for at least 5 seconds. So if we were to pinpoint that on this trace, this would be our time to interactive. And this is a really great metric because it quickly shows the differences in performance between a mobile and a desktop. You can't game this very easily. It's as true as the day. There is a brand new metric that we can use in our testing as well, which is called total blocking time. It's now built into Google's Lighthouse. although it's not visible in the UI at this point. It will be in, I believe, the next release. Total blocking time looks at all of those tasks along that timeline and calculates the total duration. So if you were wanting to maybe get an understanding of time to interactive is the moment when the page becomes interactive, but total blocking time is all the work that had to be done for it to get to that point. Generally speaking, the most effective thing that you can do is just delete all of your JavaScript. There are some measures that we can use to reduce the amount of JavaScript without having to go and delete everything. Some of those are, we can visualize the size of our dependencies using either the Webpack Bundle Analyzer or the Source Map Explorer. For the Webpack Bundle Analyzer, you'll run your Webpack command as usual, except you'll add a couple of extra flags to say we want a profile, and we want to turn it into JSON, and we want to push it into a stats file, and then we can run the Webpack Bundle Analyzer on that, and then we'll get this graphic will open in your browser running on localhost, and you'll be able to zoom in and explore each of these bundles. So if you're using, if you're breaking your application into chunks, you can go and explore each chunk and see where the dependencies may lie, and you can find things that are maybe bigger than you expected. Same goes for the Source Map Explorer, which is maybe the one that you would choose if you're on an Angular project. ng-build will automatically export source maps, I believe, so you don't actually need that flag unless you're targeting production. I think then it gets turned off. But then you can go and run it on your built app file, and again, you can go and explore your dependencies. There's also a really great website called Bundlephobia. Has anyone seen this before? Only a couple. Cool. OK, so Bundlephobia allows you to type in any NPM package, and you can then go and see how big that bundle is if you included it into your project. So you can do this before you've even NPM installed it. You can see how big it is and how long it'll take to download over particular connection types. In particular, something that's very interesting is for the date functions library at version 2.0, we can see that the size of the library has increased quite dramatically. The reason that that happened is because they've changed the library. Before, it was only exporting ES5, but now it's doing ES 2015, so it has modules built in. And you may notice that I've highlighted that the library is tree shakeable. Wow, this is a very excited remote here. So tree shaking is the only way that you can get tree shaking is if you're using ES 2015 import or export statements in your libraries. And essentially what it means is that you can go and grab the function that you want from a library without having to include the whole library itself. So using Bundlephobia to see if your library can be updated is super, super valuable. And usually it just means that it's a small update and the package maintainer has had to go and add some details to their package. Bundlephobia also will suggest similar packages. So when you're looking at the date functions library, it'll show you how much bigger Moment is, for example, or Luxon, or Day.js, which I had never heard of until this feature was added. So it's quite good for exploring. Another thing that we can do, which is really interesting, I think, this came from Matthias, who works on the V8 team. Service workers, when they load your JavaScript, if you go and push your JavaScript into your service worker, it'll cache the bytecode result of your JavaScript. So if we remember talking about that parse and compile process, what's happening in the service worker is it takes that final compiled result that runs on your CPU architecture and caches that. So it means that when the page is run again, you're not paying that parse and compile step again. There are some caveats. You don't want to throw all of your script into the service worker, and if you read this tweet, Matthias has actually gone and explained why. But that means that it's quite an interesting process that we can get stuff off the main thread by using service workers or web workers, and we also get some extra benefits of caching. So if we were to look for some JavaScript reduction tips in general, from metrics, we want to look at the uncompressed size of scripts, use time to interactive and the brand new total blocking time. Wow, this remote. We can analyze our bundles to find the largest dependencies, and we can look for library alternatives that maybe are smaller, or they're upgraded, or they have tree shaking built in. We can remove polyfills, and we can use web and service workers to run code off the main thread. The second biggest performance issue on the web today is really just the size and the amount of requests. And this is something that we're all familiar with as builders of the web, right? But it still plagues us. Over the last year, the median size of desktop and mobile pages have grown significantly, and that trend does not look likely to stop. Not only that, but pages are making far, far more requests, and yeah. Resources do differ based on context, though. So when I looked at stats of just a marketing site, I think it was stripe.com, we can see that they're shipping quite a bit of JavaScript, a little bit of images, and they're using some web fonts. But when we look at a content site, so a site that serves recipes and has lots of photos, they're serving nearly 5 megs of imagery. Most of the imagery not visible on the main viewport at any given time. And then if we're looking at a single-page web app, again, we've got a lot of JavaScript and a little bit less images. So depending on the industry that you're in or the type of site that you're building, the types of requests might be a little bit different. But there are a couple of strategies that you can use to keep those requests in check. Firstly, you can use performance budgets. Performance budgets are just constraints that you agree on with your team, and you apply that to your working process. So an example of that is maybe you would say, we want to keep a particular file size below 200 KB. That might be images in general, or that might be JavaScript in general, or it might be, we want it to have a total page size of less than this amount. We can use performance scores from Lighthouse or from other tools, where we get an overall ranking of a page, and that we want to maintain that we're going to stay within that boundary. This remote. Or we can use milestone timing. So maybe we want to make sure that we reach time to interactive in less than 5 seconds. So set budgets based on context. You've got to look at it with your team. You've got to agree on the types of metrics that you want to use that are for your content. But maybe you want to think about it in the path of your journey as a team. So if you already have performance that you know is not ideal, and you're working towards maybe maintaining that you're not going to get worse, you can use a baseline metric where you can say, we're not going to let this metric go over this particular threshold. And if we do, we'll break the build, we'll alert our team, we'll have a review, and we'll discuss what we can do. Or we could maybe use them to set future goals. So if we were working on a greenfields project, or if we were maybe just committing to performance work in the future, we could say, hey, look, we expect our time to interactive to be less than 5 seconds on a desktop, being kind of a realistic goal and kind of the golden number, and less than 10 seconds on a mobile. So we can go and do that with multiple types of metrics, and quickly you can see that they're quite different based on mobile and desktop, but it's really difficult to set a target for overall and expect that it'll work on a mobile. You're really cutting yourself out for difficult work if you do that. If your team or company really, really wants to own performance, though, as a foundational aspect of your work, then you need to implement a performance system. The first thing that we can do as part of that journey is get to know performance metrics. There are a lot of performance metrics out there, and they can be used as signals for your pages, but you need to choose ones that work for you. If you're going to choose only one metric amongst your team, consider using an overall performance score, which is a very easily understood number for people who aren't technical on your team. It's a 0 to 100 scale. And the good thing about the performance score that's calculated in Lighthouse and on PageSpeed Insights and in other tools is that they're made up, the score is made up by using a bunch of other metrics, 5 of them, in fact. So time to interactive, speed index, first contentful paint, first CPU idle, and first meaningful paint. Those metrics in that order are graded and weighted. So if you wanted to influence your performance score more drastically, the first metric that you would look to try and improve on is the time to interactive. Once you've got your time to interactive low, so you've made your JavaScript main thread fast, then you can start to look at the paint characteristics of your page. If you're a content site and maybe you have great JavaScript performance, but your pages are taking a little while to become fully rendered, you could maybe use a metric like first contentful paint, which is the time it's taken before text is rendered to the screen. However, there is a brand new metric that's built into Chrome Canary as of last week called largest contentful paint. Largest contentful paint looks for the largest text, image, or video content on your page. So if you can see in this graphic here, at the very left-hand side, we can see first contentful paint would have fired when the first text was visible on the screen. And I think we can agree that the page wasn't really useful in this case. Whereas if we go all the way across, we can see that the browser was looking at the largest block-level element, in this case the text headline, until it got to the image, and then it decided that that was the largest contentful paint when the viewport became available. So if you were to use this as a metric, this means that you don't have to look at what your pages are doing. You can get this and understand of when a page becomes quite useful to a person. So now that we've established like some big performance issues and we talked about a couple of metrics that can use to send signals, it's critical that we get a handling on framing those metrics and how we actually utilize them. This is where we need to get data about our customers. Kinds of things that we want to know in this case is we want to know how many of our users or customers are on a desktop or on a mobile. The web is predominantly mobile in traffic, but it may differ for your site. If you're building an application where people are logging in and looking at analytics, they maybe not be on a phone. They may be using a desktop a client instead of that. So you have to look at the actual raw numbers, go into your analytics software and get that. We want to look at the types of mobile devices. We want to look at where our customers are, the majority of them. We want to look at the average connection speeds in that majority location of where your customers are. And we want to look at the connection speeds of where your users are actually using. And I'm going to show you how to do all of that now. So I went and looked at the devices for caliberapp.com, my company, and I was quite surprised, actually, to see that the Nexus was, in terms of mobile traffic, was far and away the most popular device. We'll get into why that's interesting in the next slide. So the second most popular device was an iPhone X in this case. We go and look at the benchmark score using geekbench.com, and we can see that its single core performance is ranked at this magical number of 4,000 here. But if we go and compare that to the Nexus, which was over 70% of the mobile devices that use caliberapp.com, we can see that it's about, a quarter of the speed. Now, Geekbench's benchmarks don't definitely translate to JavaScript main thread performance, but it is a very, very good indicator of the single-threaded performance that you'll see on that device. And so if you want to use this to formulate an idea of what your customers are experiencing, this is a pretty good test, apart from building a device lab and going and testing it yourself. So I also added on the price there. We can see that the Nexus was, 71%. It had a far slower Geekbench score, and it was also far cheaper, which is just interesting in general. A site that we can use to understand the speed of mobile networks in any location around the world is opensignal.com. Every 6 months or so, they'll put out a new report, which you can use to go, find the report for Germany, and you can look at the average connection speeds for upload and download based on different carriers and broken down in all sorts of different interesting ways. In Germany, 3G is still a very, very real network that people are on as your device switches off LTE. If we look at the largest carrier by far, Telecom, we can see that the average download speed is about 10 megs per second. Wow. Very excited. We can also use something called the Chrome User Experience Report. Is anyone familiar with this or heard of it? 1, 2 people, 3 people. OK, interesting. So what the Chrome user experience report is when you're using Chrome, and I wouldn't be surprised if you didn't know this, Chrome is actually sending back some metrics about your user experience back to base. But we can go and use these to our advantage. They're built into a big table or a big query table, and we can go and it's publicly available. You can go get an account, and you can write a query like this one over here on the right. In this case, what I've done is I've gone and looked for requests on bonappetit.com, and I'm selecting a couple of interesting properties. Firstly, we're selecting the effective connection type. So there's a new browser API where the browser will characterize your connection speed. It's not your actual connection speed. So if you're on an LTE connection, it might still be characterized as a 3G connection based on the download that actually occurred for the page. So all of that information is sent up to Google, and then they make it available in this report. So we don't need to run or to own bonappetit.com, but we can go and write this query, and then we can get some information. It's completely anonymous data, so you can't do anything particularly creepy, but we can build an interesting profile here. What we can see is that on Bon Appetit, for phone, most people are using a fairly reasonable connection speed. It's characterized as a 4G. So user experience is a spectrum. And if we're gonna test our work, we need to test it within those bounds. So we've already identified that the slowest phone in the context of calibrapp.com was a Nexus 5. And we've already established that here in Germany, the lower end of the network speed, which is still a very big group of our users, are on a 10 Mbps network. And then at the larger end of the scale, where you've got the iPhone that's 4 times faster, we know that most of our users are going to fall somewhere within that spectrum. And so we need to test within that. And we need to get our metrics within that as well. So when I go and run some performance metrics over the site, bonappetit.com, we'll see that the performance score has indicated 7 out of 100, which is not very good. I think you can agree. And what's really interesting, remember we were talking about there's 2 big problems that we see on the web. There are the number of requests and how big they are, and then there's the JavaScript main thread performance. Now looking at the metrics from here, we can tell very, very quickly that, okay, well, on a not very fast network and on a not very fast phone, we managed to reach first contentful paint in 5.4 seconds. It's not too bad, considering. But we can see that the main thread was very, very hampered by performance. So if we were to look at these metrics and say, where would we put our effort into first, it would absolutely be into main thread JavaScript performance. By the way, the global average TTI is about 19 seconds. So Bon Appetit are way over the global averages. When we're doing performance work, it can be really easy to have a theory and fall into a trap and then try and deploy it, and then it doesn't work, and you're really left kind of being fairly disappointed. So what I'd like to encourage you to do is to form a hypothesis and then test that. And try and do that as quickly as you can without having to deploy, without having to sort of waste that time. One way that you can do stuff like that is just right there in your DevTools. So in Chrome, you can pop open the network tab, and you can click on, in this case, I'm looking at a double-click add. And I've just right-clicked on it, and I can say block this request domain altogether. So my DevTools is now not going to allow that page to load that script at all. So then we can go and then go back to the performance panel and then run another trace to say, well, what if we didn't have double-click on this page? What performance impact would that make? Another thing that we can do is use something called local overrides. So again, starting in the network panel, we can click on a script and say, view in the sources panel. And then we can click onto the overrides side menu. And we can select a folder where we say, we're going to allow this code area on the browser to be saved to my desktop. We click Allow, and then any changes that we make to that HTML file or to any script or any part of the page will be saved onto my machine, and then when we reload the page, it'll have those changes intact. So we don't need production access to do this. We can come up with a theory, and we can go and test it really, really quickly. One thing that I like to do during this process is use a performance workbook. So I start with a table. I have a couple of columns, an estimated gain. So I'm going to come up with a theory of a thing that I could possibly do. I'm going to put in my estimate of what would happen if I did it. So here's an example. If I were to preload the fonts on this page, knowing that a font is something that relates to browser painting. Okay, well, I think it will save 3 to 5 seconds in FCP. We can then go and use local overrides and add preload to a page and then see what the impact of that is. We can see that the achieved gain was about 3 seconds to first contentful paint. And the other thing that I like to add is the difficulty and the estimated cost. And in this case, I think this is the kind of change where you would just go and do it. And you would go and do it without consulting your team. You would sneak it in, and then you would high five because you've done something fantastic for font rendering performance. It's very easy. There's no politics involved. So if we're looking at maybe using font display swap, we could get instant text rendering because we're not waiting for the web font to be downloaded. That seems fairly easy as well. May depend on your code base. Estimated costs, again, low, do it. Straight away, go and do it. OK, but what if we removed all of the web fonts? What would that give us if we've already done these other two things? Well, probably it wouldn't change the rendering performance very significantly, but we would load 50 KB less. Is that worth it? Maybe. But we could have some political hurdles with the branding team who really want to see that web font there. So maybe that's something that we need to talk about with our team. We could rewrite the web app, the whole app in React, which is quite hard and very expensive. Or we could just keep writing JavaScript until the website is fast, which does not actually work. So maybe that's not something that we would do either. Same goes with removing ads. You know, if we go and block the double-click ads, and maybe we improve the page performance by 10 seconds, is that something that we'll do? And does that cost us all of our revenue? Maybe, but maybe it's something that we can do on a lower-end phone and leave the ads on desktop. These are all things that don't need to be done in the same level experience. If we're thinking that our users' performance, the way that they perceive performance is a spectrum, then maybe it's appropriate to do so on a mobile. I'd like to definitely recommend that you review as a team regularly. So evaluate all the performance work that you're doing and all of the things that you're trying. Get together and see and talk about what worked and what didn't. One thing that we've done at Calibre is we've invented this report that we call Insights. And so if you're monitoring your site in Calibre, you can go and turn on this report to receive it weekly or monthly. And it just turns up in your email. On a Monday morning. And so we show the overall performance score and any changes that have happened since the last week. So it's a really good way to kind of look at performance without really having to pay attention to it. A lot of teams that we work with do so by putting it onto a dashboard or by sending a spreadsheet, whatever it is, just make sure that people can see it. The other thing that we do in Insights, which I think is really, really important, is that we show user experiences. So we have a profile where we say it's on an iPhone 6 on a slow 3G connection, and we also enable an ad blocker to see what do users who run an ad blocker and have a phone, what did they experience, and how has that changed in the last week. So performance work has to be continuous. As I mentioned at the start, it's not something that can be bolted on after the fact. It must be part of the process from completely beginning to end. That means that teams have to understand their user base. It means that they have to start set targets together and use monitoring to get regular signals throughout that process. In development, you can use your browser's devtools to throttle CPU and network speeds in order to see how pages differ to the full-speed localhost. You can build performance into your continuous integration suite. So you can block from merging if performance has declined. You can avoid shipping regressions to your customers. You can automatically compress images and do things that are just a little bit frustrating to do as a user as part of your job. But just make sure that performance is visible and keep everyone involved. Modern deployment hosting environments like Zeit, Netlify, and Heroku can automatically deploy your pull requests to secret URLs where you can use them for QA or performance testing. If your deployment environment doesn't allow you to easily have a production-like environment to test on before your code reaches production, then you need to use a platform that allows that to happen. So in summary, we've covered a lot of steps today and talked about specific performance metrics and tools and things that you can add to your process. But I can't stress enough that your organization, to be successful at performance, needs to understand that it's a foundational aspect of the work that you do, and it needs to be there all of the time. Things that we can do: know common performance issues and how to identify them and use metrics to see them quickly. Track the right metrics. Use budgets and alerting to keep your team informed of changes. Wow, that's right. Test using real-world situations. Review regularly, form a hypothesis, prove it, fix it, make all your environments the same, and try to get signals about performance everywhere that you can. For a full review of my talk or slides, I'll post a link directly after I get off the stage. Retweet it on Twitter, share it in your Slacks, yell it into the sky. Thank you so much for having me. Let's make the web fast together.